the curve lies, P lies on the curve and has x coordinate of 1. So what I'm going to do is I'm going to just find P first. I'm sure we need to find P. Alright, so since x is equals to 1, so sub here, minus 1 square, 4 times 1 minus 6. So I will have, this one here is like that. So my P is 1 and negative 3. Okay, so the tangent meets the curve at P, meets the x-axis at A, and y-axis at B. So in order to find the tangent, so when I have my tangent, means it's dy dx, right? So when we are looking at dy dx minus 2x plus 4, the gradient at x equals to 1, this is 2. This is the gradient at P. So what happens here is that the gradient will, we know that the gradient is 2, and we know that this is the point, right? So y minus y1 x, like that. So y equals to 2x minus 2 minus 3. So this is the equation of my tangent. So once I have the equation of my tangent already, I can find coordinates A and B. So this one over here, right, I will find from here, this one is y equals to 2 times 0 minus 5. So this one here is B will be 0 and minus 5. Then this one here is 0 equals 2x minus 5. My x will be 2.5. So this one A is 2.5 and 0. So I have everything from here. Okay, so if let's say we need to find, right, the what they want us to find, they want us to find the area of the triangle. Okay, so O is the origin. So let's say if we sketch it out, right, let's say I just sketch out like that just to visualize better. So B is negative 5. So negative 5 is this one. Then A is 2.5. Okay, so one is B, one is O, this is A. So what we are finding is the right angle like that. So if in this case, right, if you need to find the area of this triangle, can just do half times base times height. So the base is 2.5, and then this is, I don't put negative because it's just the length, so put 5, okay? So half times 2.5 times 5. So this one here will be 6.25. Put your units square. So this one will be your answer for part I. Then for II, right, so when we are looking at part II, what I have is that the Q, right, it lies on the curve. So the normal to the curve is parallel to the tangent at P. So let's say I just anyhow draw and then I visualize, okay? So what I have here is, let's say I have a curve. So this is a set face curve. So set face curve, I just anyhow draw. This is the P one. Okay, so they say that the normal to the curve is parallel to the tangent. So let's say if I copy paste for this one, copy, so I paste here. So normal, let's say this one will be the normal now. So if this one is the normal, right, that means this one here is this orange line is the tangent. So if this orange line is the tangent, right, what happens here is that this gradient was 2. So that means this orange line, the gradient is negative half. So since every time you want to do dy dx, right, it must be gradient of the tangent, correct? Not normal ma. So gradient of the tangent, so this one dy dx equals to negative half. So go and solve from here, negative 3.5. So x, right, is actually, x is actually your 2x. No, this one should be minus 4.5. Okay, so 4.5 divided by 2, this x, right, is actually 2.25. What they want us to find? They want to find the coordinates of Q. So I'm sure you know how to find the coordinates of Q. You should be able to go and find Y. So sub back, right, because it lies on the curve, right? So you sub back inside here. So if you sub back inside here, So this is minus 9 over 4 square plus 4 times 9 over 4, then minus 6. Okay, so you can write it as a fraction maybe, like that. Okay, or you want to write, don't round off. So for this one, right, you must write your Q as this one can be written as 9 over 4, the 2.25 lah. Then this one here will be negative 33 over 16. So anyway, for this question, right, I want you to know is always remember the gradient of the tangent to the curve. We just know it's dy dx, because in order to find the gradient on the point of the curve, right, you always draw the tangent.